All right,
Something.
almost. All right,
All right.
and here's Mark and his restful robots.
All right. Hello, Nosebridge. I'm Mark. I'm working on a robot, and I wanted to talk about robot software. Um, this is the robot I'm working on. It's called Birdhouse. Hi there. Uh, this is the robot I'm working on. It's called Birdhouse, and Birdhouse is a remote launch pad for drones. Um, uh, is that working now? Okay. So it's a remote launch pad for drones. Basically, it takes a consumer drone, wraps it in a lot of automation so that when your drones are at rest, it acts like a recharging shelter. And then when you want to fly, it opens up into a launch pad and you can launch your drone, fly it around, or re-land. And it has a bunch of telepresence sensors on it so that you can actually do this remotely. So you're actually in your house, your drone lives outside in Birdhouse in your backyard or on your roof. So it's basically, it turns your drone into a service. Now, I just reached a point where I'm adding motors to this, so what's the software and what's the hardware that actually can make that happen? So basically what I'm going to talk about is it's standard maker hardware and a bunch of open source software. So you could actually use this same stack, the same hardware. It's basically standard maker stuff, so Raspberry Pi, master, microcontroller slaves running motors and lights, and then a mobile app running on iOS right now. And you get so this stack, and it's open source software on the Raspberry Pi, which is I'm going to focus on. Now you can use this stack to run pretty much any robot. It'll scale down if you want to run a little like RC tank, or you could scale this up to automate like a giant farm with thousands of plants. It'll actually work in both of those contexts, and actually both of those systems they would all present as one robot, one virtual robot. Okay, so regardless of the robot, robots, for something to be called a robot, it's got to do this robotic thing, which is called an event loop. And an event loop is, when a robot goes off on its own and it's kind of navigating or doing this robotic thing, this is an event loop. And this is an important design pattern in robotics, right? So, and it consists of three parts. First, the robot needs to read the world through sensors. Secondly, it needs to interpret all that sensor data into a motion plan, a reactive motion plan. And then third, it has to execute that motion plan. So it blinks lights or it moves motors or whatever to change the state of the robot to kind of realign with the world. And very importantly, the third step, running the motion plan, this is where things get tricky in robots because the motion plan can't block the event loop. The robot needs to keep sensing the world. It needs to keep reacting to the world. It has to stay reactive and keep up. So it's very, very important that the motion plan runs in the background, runs asynchronously. So that's a lot of the secret sauce that's in here that we're trying to implement. So I'm going to go through the software stack on the right. I'm going to focus on just what's running in the Raspberry Pi. I'm going to go down, talk about sort of what the software is, and then I'll kind of do a walkthrough of sort of one loop iteration so you can see how it plays out in the stack. At the top of the stack, we've got just a web server. So Nginx and WSGI they're a web server. I won't say any more about that. They pass HTTP and REST calls down to Django. So this is a Python stack. And by the way, this is kind of agnostic. If you're a JavaScript person, you can rip out the Django stuff and put Node.js in there or whatever you want. These other sort of design patterns will still play through. It passes through to Django. Django is a couple of things. First of all, Django is a web framework for building dynamic applications with Python, but it's also a generic Python app container. So in my case, I'm running two additional apps. One is this Django REST framework, or DRF, and that implements a REST protocol. And then another application is Django Channels, or Q. I'm actually evaluating both, and I'm running them in parallel. I'm just going to say Django Channels. Django Channels allows you to run your own private pool of worker processes. And in my case, these workers are actually dedicated to running the motors. So I've got one worker process provision for running a motor. I've got another that's running the lights, another one that's running the sensors. Okay. And then if you look at these yellow dots, the yellow dots represent something called 0MQ. 0MQ is a really magic bit of software. I could spend 2 hours on 0MQ alone. But it's an asynchronous message bus, and what that means is you give it a message, and it will deliver the message in the background, but it returns to the foreground immediately. And I mean really fast. 0MQ can process tens of thousands of messages in a second. It's super, super fast and amazing. And that's the kind of secret sauce of how this system is asynchronous. Okay, so how does this work in my event loop? Okay, so the first part of an event loop, like I said, is you read the sensors. In my case, I'm slaved to a drone that's flying. So I go into event loop when you're flying. So when you're off flying, I'm keeping track of the drone. I'm actually getting a telemetry stream from the drone, and that comes into here as a series of REST calls coming in right here. So that's the first part. I read the sensors. So they're not really my sensors. I'm reading the sensors from the drone. Now the next thing is I have to interpret that. So that sensor data comes in to a REST endpoint, and that's where my logic is. So I look at the data and I say, do I need to re-aim the camera at the drone? Do I need to open or close because I've passed a geofence going out, or I've passed a geofence coming in and I have to open the flight deck to accept the landing? So if that's the case, I decompose that REST request into a set of 0MQ messages, and I dump them onto the 0MQ bus. And those messages then it returns immediately, returns up to the REST API, and that's how my event loop stays fast. So the request comes in, hits the bus real fast, and then I go back to my event loop. The messages then propagate over to the worker threads, and this is a microservice architecture basically. Each one of these threads has its own addressable endpoint on the web service framework. And then inside the worker, it'll either hit a virtual driver or a real driver if I have a motor. And the virtual and the real motors simply have to obey the same API as far as the microservice goes. And as long as you obey that, everything above there is okay. So I can actually, as long as you have this set up, I can do 95% of the Raspberry programming, and I can do 100% of the mobile app programming, whether I have hardware or not. So as I'm developing my hardware, I can develop the software as well. So there you go. So basically the idea is from the top we're going high latency to low. A blocking call comes in. It gets decomposed into a bunch of asynchronous calls on 0MQ, propagates into the background threads, and plays out in the motors and everything. That's about it. Thanks a lot. I think I'm out of time.
We'll take a couple questions, and then we'll take a brief break. Any questions?
Did you really need DRF to decompose the incoming JSON or whiskey string?
What I didn't have time for is actually the name of the talk is RESTful Robots. And the DRF part is actually, REST is the full REST protocol actually treats a resource, a RESTful resource, like it's a database table. So you can actually read or write or update or delete. So what I haven't shown is actually there's an abstraction that I wrote where you can actually interact using REST calls, and you treat Birdhouse, you treat the robot like it's a database table. So you read and write fields, and that changes the state of the robot, and then it responds like that. So, but it responds to a full RESTful interface, so it can integrate into other sort of RESTful resources in a bigger network. So if you had 1,000 birdhouses, they'd all kind of present as a kind of conventional RESTful resource. I hope so. I hope so. Yeah, that's the idea. I'm actually this is a startup, so I'm trying to get this bootstrapped. So I'm a sole bootstrapper and just trying to get it going.
What was your presentation software that enabled you to?
It's cool. It's Prezi, Prezi. Yeah, it's an online app. It's really easy, and it's the free version I'm using here. So.
Got any video of the thing in
Those animations that you saw on my website, those are basically animated 3D models. And I could show you, the one thing that I've motorized so far is the lift system. So I've actually got an elevator lift system which is now motorized, and that's where I'm adding motors. So I've kind of hit some mechanical engineering milestones. I started adding motors, and when you add motors, you have to add software. So that's how this all came about.
Where's your website?
It's flyingchair.co.
All right.
Thank you.
thanks. All right, so we're